Alright, we are working with a differential equation, and it's t y prime plus y equals t plus 2t ln t. Alright, well, at first it might look pretty menacing because you could think that, oh, we have variable coefficients and all kind of crazy stuff. But let's take a look. We have a t here, here, and here too. And it would be good if we would have it in standard form, right? So we don't have anything in front of the y prime. So let's start with that. Let's see where it's gonna take us. I divided the equation by t, and here's our new look. We have y prime plus 1 over t y equals this whole thing, 1 plus 2 ln t. Now, this is a first order differential equation, and if we look at how usually formulas describe this type of equation, we have the y prime plus pxy equals qx. Now, let's see, we're going to designate this as qt because we are working with t, and in front of the y, we're going to call 1 over t as pt, right? These two components. So, this will help us decide that we're going to go ahead and use the integrating factor method. Good, now we have a game plan, so let's go ahead and start the work. So for the integrating factor, let's find the factor. So e to the integral of pt, for us that's 1 over t, dt right here equals e to the ln t, which e and ln simplify it out, and all we have is a t. Now we're gonna take our original equation and multiply both sides by the integrating factor, which is t. So I'm gonna take this form of it, multiply this side by the t, multiply this side by the t. Now for the next step, d over dt parentheses ty equals, and here t times, just multiply it out, t times 1 is t, t times 2 ln t is 2t ln t. Now on this side, what happened on this side? Well, all you have to remember that this turns into this because of this, the product rule. Remember when we had to multiply these two and then take the derivative? Then it gave you this. Now this here, we are going backwards with this rule. So in this line right here, we arrive to this side, and we're simply going to take this side and turn it back into this side. And that's what you see in here. I took this and backwards product ruled it into this. That's all there is. And this is why the integrating factor method is actually so useful, because it helps you clean up this side real fast. Now I'm going to take the integral of both sides. On this side the derivative will disappear, becomes only ty. On this side I'm going to have the integral of this whole thing, which I can break into two integrals. Integral of t dt plus integral of 2t ln t right here. Now let's go ahead and find these two. To continue this, I'm going to bring the ty down here equals this, whatever we get from this integral plus whatever we get from this integral, right? This one is fairly easy. Go ahead and solve it, bring it down right here. Then plus what we're going to get here. Now this one's not that easy, needs a little bit more work. So let's take the 2 out in the front right away. So we have 2 times the integral of t ln t dt. Now this is a prime customer for integrating by parts. Here's the formula in case we forgot. The integral of u dv equals u times v minus integral of v du. This is what we're gonna use to figure this guy out. So we're gonna have to decide which gonna be u, which gonna be dv. I'm gonna pick t to be u and ln t to be dv. Take the derivative of this one and integrate this one. Now we have all the components that we need to fill out the formula, right? So 2 times the 2, we can't forget that, in parentheses, everything that we're gonna get from here. So this is the u times v minus integral of v du, integral of v and du. There you go. Now let's go ahead and simplify this. This side comes down, stays unchanged, so 2 integral t ln t dt will be equal to this side. So I'm gonna multiply 2 times these, so there you have it, this 2t squared ln t minus 2t squared. Now minus the integral, but 2 times, right? Don't forget the 2. Here we can see that I can break this up right away into 2 integrals. So minus 2 integral the first t ln t dt, and minus minus plus the 2 from the beginning times the integral of t dt. And I'm not gonna write it down, I'm just gonna go and instantly solve it. T squared over 2. Okay, let's continue. In our next line, we can see that on the left hand side we have an integral with t ln t. On the right hand side we have another one, integral t ln t dt. Okay, let's collect these two like terms. I'm gonna put it on the left hand side. That's gonna give us 4 integral t ln t dt. Everything else, what's left on this side, just stays unchanged. Now we have 4 integral t ln t, but where did we start? We started up here, and I had a 2 times integral t ln t. So let's just divide this whole equation with a 2. So at the next step, when we finally figured out what it is, it'll be easy for us to just go ahead and sub back here, right? Because it's exactly the same thing. So 2 integral t ln t dt equals this whole thing. Simplify it out, and we're gonna end up with a answer t squared ln t minus 1/2 t squared and plus this cute little c. Okay, let's not forget that guy. Now finally we can fill our next step out. Here, remember, we just brought this one down, ty equals, we solve this integral, and now we solve this guy, which becomes this right here. In most cases this would be just fine, a good answer, but a lot of times people want to see the answer with y by itself, right? Okay, so let's do that. Let's clean it up. So we're gonna divide the whole equation by t, and after doing a little simplification, we can finally get y equals t ln t plus c over t. Okay, this is the answer to our differential equation. Now sometimes the problem comes with a situation where it's inside of an IVP, initial value problem. So let's say, just in case, if we also had given that y1 equals 5, then we could go ahead, plug into this equation. Everywhere we see a t, we'll put a 1, and instead of the y, we'll put a 5. After cleaning it up, we can see that we finally found c, which will be a 5, and by going ahead and plugging back into this equation, we can find that y equals t ln t plus 5 over t. And that is our final answer. Thank you guys for watching. Please subscribe and like the video for other people can find it as well. Have a good day.